Chem is try. You just try. And through practice, you will be perfect. Through practice, it will make perfect, and everything shall be fine. So when we are doing organic chemistry, the first thing, this is the chemistry. This is chemistry of carbon and hydrogen, except for carbonates and hydrogen carbonates. Why do we say except for carbonates and hydrogen carbonates? This is because the two, the carbonates and the hydrogen carbonates, are studied under carbon and its compounds. Then the interesting part again is that we are dealing with carbon and hydrogen. Why carbon? Why are we interested in carbon? Why carbon? Why is it that carbon is so unique that we must be interested in studying it? The uniqueness of carbon. Number one, the reason why carbon is because, number one, carbon can bond with itself. Carbon can bond with itself to form carbon and carbon. This is carbon bonding with itself. Number two, carbon can form branches. Carbon can branch. Number three, carbon can form single bonds. Number four, carbon can form double bonds. Number five, carbon can form triple bonds. And number six, carbon can form rings. And this also can be a ring. That is the main reason why we are interested in carbon, because of its uniqueness, because of these properties of carbon. Next class, we deal with homologous series. The homologous series, organic compounds are classified. Organic compounds are classified into groups called homologous series. What is homologous series? Homologous comes from the word homo, which means same. A Greek word homo, which means same. That's why in history you could say Homo erectus, Homo sapiens, Homo habilis, and if you like you can say homosexuals. And again, logos. Logos means molecules. Therefore, homologous means same molecules. Homologous means same molecules. So homologous series these are organic compounds with the same general formula. Organic compounds with the same general formula same functional groups and the successive members of the group, successive members of the group differ by CH2 group. This is homologous series. From here, we have various types of homologous series. Types of homologous series. Number one, we have alkanes, we have alkenes, we have alkynes, we have alkanols. From alkanols, alcohol, we can get alcohol from alkanols. Then we further have aldehydes, aromatic, alkanals. Aldehydes, aromatic, and alkanals are beyond your scope. You will study them later on at advanced level. So what we drink, what our parents drink normally comes from alkanols. If you take alkanals, you become blind or you die. So from here we'll start with alkanes. We start with alkanes. Alkanes are saturated hydrocarbons with the general formula CnH2n plus 2, where n is an integer. Integers are whole numbers. Therefore, as per our syllabus, we'll only deal with the first 10 alkanes. So we will say when our n is 1 up to the 10th value. When our n is 1, we simply replace it from the general formula CnH2n plus 2. So when n is 1, you replace here n as 1, that is C, 1, then H into 2 times 1 plus 2 equals to, this is C1, H 2 times 1 is 2, 2 plus 2 is 4. C1 H4 is methane. Methane. Meth is a Greek word meaning one. N comes from the parent alkanes. Alkanes. So they take the word N. So alk is a continuous chain. Al means continuous chain, or the aliphatic compounds. Aliphatic compounds, continuous chain. So methane is an alkane with 1 carbon atom and 4 hydrogen atoms. When N is 2, you simply place C1, Cn, N is 2, into H, 2 times 2, plus 2. This is going to give us C1, 2 times 2 is 4, 4 plus 2 is 6, C1H6. This is an ethane. When it's 2, it is ethane, eth. When N is 3, it is C3, H3 times 2 plus 2. That is C3, H8. That is propane. I want you to notice a trend, class, so that you now just make your work easier. We have C1, this is C2, sorry, C2. We have C1, C2, C3. So our next is C4, C5, C6, C7, C8, C9, and C10. Then we have H4, H6, H8. There is a series by which they differ by H2. H2, H4, H6, H8. The next one is H10, then H12, then H14, H16, H18, H20, and H22, where N is equal to 4, N here is equal to 5, N here is equal to 6, N here is equal to 7, N8, N9, and finally N10. From propane, when it has 4 carbon atoms with 10 hydrogen atoms, is called a butane. When N is 5, C5H12 is a pentane. C6H14 is hexane, from the word hexagon. Pentane, from the word pentagon. Hexane. Pentagon is a 5-figure. Pentane, pentagon. Hexane, hexagon, 6. 7 is heptane. 8 is octane, octagon, octogenarian, octane. 9 is nonane, and 10 is decane. Are we together, class? Thank you. From here, we can see this structure. These are called the molecular formula. Molecular formula. So from here, we want to get the structural formulas. So keep these in mind. We want to get the structural formulas. To get the structural formula, we will open the structures. So we can choose to do around the first 3 from methane to 4, the first 4. So the structural formula of methane. Methane is CH4. Methane is CH4. So from here, I want you to be attentive, class, and listen carefully. From here, we want to, from the periodic table, we want to know where carbon and hydrogen lies. So I will draw a periodic table with the first 20 elements. So our periodic table is here, class. This is group 1 elements, group 2. These are transition elements. Then group 3, group 4, group 5, group 6, group 7, and finally group 8. These are transition elements. So class, be very careful, be very keen. I want to tell you the easiest way to get the first 20 elements, and it is in a song form. So you will sing along. Prepare yourself to sing along. We must enjoy this lesson, class. So you start by saying, how he likes beer, but can not obtain food. Nelly nags Maggie. All smart people study classical arts. Can, can't. We want to identify these elements. The first element is hydrogen. Second element is helium. Third is lithium. Fourth is beryllium. Fifth is boron. Sixth is carbon. So we will be looking at this. 7 is nitrogen. 8 is oxygen. 9 is fluorine. 10 is neon. 11 is sodium. 12 is magnesium. 13 is aluminium. 14 is silicon. 15 is phosphorus. 16 is sulfur. 17 is chlorine. 18 is argon. 19 is potassium. You can also call it kalium. And 20 is calcium. Class, I want us to sing along. Let's start. How he likes beer but cannot obtain food. Nelly nags Maggie. Nelly nags Maggie. All smart people study classical arts. Can, can't. First 20 elements. So when you put them in the periodic table, we used to put hydrogen here. Okay, these are period 1, period 2, period 3, period 4 elements. So nowadays we write our hydrogen here. Why? Because group 1 elements are metals. So we represent our hydrogen as here. So instead of writing it here, you write it here. Then from hydrogen, you write helium, then lithium, beryllium, sorry for this, but it's okay. So group 3, group 4, group 5, group 6, group 7. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then helium is way up. Sorry, that's helium. Goes with this. Then neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, neon, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. This should be argon, not there. Sorry, let me just draw it again. Class, I think there's a little bit of confusion, but it's an easy one. Just the same trend. Group period 1, period 2, period 3, and finally period 4. So group 1. Then here we have transition metals or elements. So group 1, group 2, group 3, group 4, group 5, group 6, group 7, and finally group 8. Good. So from there we have how hydrogen, we said it comes here because it is an nonmetal. How he likes beer but cannot obtain food. Nelly nags Maggie. All smart people study classical arts. Can, can't. Very good. It's coming in very well. So from our table, we are interested in carbon. And carbon is number 6. With the electronic configuration of 2 to 4. Now, from this statement, carbon requires 4 electrons in the outermost energy level to make it stable. Remember, we said we are starting with methane. Therefore, carbon requires 4 electrons from hydrogen in the outermost energy level to make it stable. So, if we want to draw the structure, how they bond. Remember, when they bond, nonmetals, when nonmetals bond, that is carbon and hydrogen, they bond covalently, that is covalent bonding. When a metal and a nonmetal bonds, it is ionic bonding. But when a metal and a metal bonds, it is called metallic bonding. Therefore, for the nonmetals, they will bond covalently, covalent bonding. So we want to show how carbon bonds with hydrogen. So we have that carbon. Then carbon already has 4 electrons here. 2, 3, 4. Identify them. Then we need 4 hydrogen atoms. So when we have hydrogen, I'm using different pens so that at least we can differentiate. So if these are hydrogen atoms, then hydrogen has 4. So you simply, I'm using X to show that this is electrons from carbon, electrons from hydrogen. So this is the structure, which can also be opened to as C. We can open this to C, C, then with hydrogen atoms. So this is the structural, This is the structural formula for methane. Now we go to the next one, which is ethane. Ethane is C2H6. So this one we will move a little bit faster. We show carbon bonding with another carbon. Carbon bonds, those are the electrons. Then we have 6 hydrogen. So every other one will take 3 hydrogen atoms from both sides. So if we have hydrogen, they donate 1 electron, 1 electron, 1 electron, 1 electron, 1 electron, 1 electron. So this is ethane, which can also be written as C, carbon and carbon bonding. Then you only fix the hydrogen atoms. The last one that we can do is for propane, so that we save time because they are 10. So for propane, so instead of drawing it in circles form, we will just write the formula of propane, which is C3H8. So therefore it's C bonding, carbon, carbon, carbon bonding, and then you only fix the hydrogens. This can also be written as this. You write as C with how many hydrogen atoms? 3 hydrogen atoms. Then another C with 2 hydrogen atoms. Then another carbon with 3 hydrogen atoms. This is the closed structural formula for ethane, but this is for propane, sorry. This is the closed structural formula for propane, but this is the open structural formula for propane. You can go on and on up to the 10th one. From here, class, we will go to what is called nomenclature. Nomenclature, or is also called naming. You've seen we've started naming from methane to decane. Now we want to proceed with further naming. Suppose there are branches, because we said carbon can also form branches. Suppose it branches, how do we name them? So in naming, we use the IUPAC. IUPAC is the International Union of Pure and Applied Chemistry. IUPAC is like the ID name, like Paul Owino Babu Ongeli is the ID name. They are those names that you are given by your parents from mtaa, daddy, mami. Those are not names in the ID. So the ID name, jina ya ID ya chemistry inaitwa IUPAC, the International Union of Pure and Applied Chemistry. Together? So from here we will start naming them. If we start naming by one, let's take for example that. The first rule, make sure you clothe. Make sure you clothe carbon. Clothing means you show the bonding. It bonds with hydrogen. If you leave it without this hydrogen, this is wrong, because you must show how it bonds with hydrogen. So in naming this, the first step, write down, identify the longest continuous carbon chain. Again, identify the longest continuous carbon chain. Number one. So in our case, if we identify the longest continuous carbon chain, here is 1, 2, 3, 4. You just count. Longest continuous carbon chain is 4. And number 4, we know very well that it is butane. Okay? What of if we want to name this? Make sure you clothe it, or uivalishie mask. Saizi kuna corona, if you don't put on a mask for the carbon, then it may be infected by corona. And you know that is now dangerous. So you clothe carbon with hydrogen. The first step in naming, identify the longest continuous carbon chain. In our situation, the longest continuous carbon chain can be, pay attention class, hang on my lips and be with my hands. 1, 2, 3. What of I want to move like this? This is horizontally. What of horizontal then vertical? 1, 2, 3. What of starting from here? 1, 2, 3. Therefore, the longest continuous carbon chain has 3 carbon atoms. 3 carbon atoms. And the moment it has 3 carbon atoms, it is a propane. Propane. But we've not finished naming it. Why? Because we've only named that. That is propane. Anything else, write down, anything else outside the longest continuous carbon chain is a branch. Therefore, identify the branch. So if this is our longest continuous chain, we can see there's a branch here. So we want to identify what this branch is. What is this branch? We want to name the branch. From here, we can see the branch has 1 carbon atom. It has 1 carbon atom with hydrogen atoms, but there are 3. And then there's this one here. 1 carbon atom with 3 hydrogen atoms. but it has one hydrogen atom less from the parent alkane group. Are we clear, class, or am I confusing? From here we have a branch. The branch has one carbon atom with 3 hydrogen atoms, but there is less from the parent. The parent, if we have CH4, this is methane. This CH4 is methane, but we have CH3. So what is this CH3? We have carbon atom, 4 hydrogen atoms, 3 hydrogen atoms. Therefore, an organic compound, an alkane from here, an alkane with 3 hydrogen atoms less in our situation is called an alkyl group. It is an alkyl group. An alkane with 1 hydrogen atom less is called an alkyl. Class, alkanes with 1 hydrogen atom less is called an alkyl. Therefore, which alkyl group is this? It has 1 carbon atom. If it has 1 carbon atom, it's called a methyl. From the word methane, which is the parent alkane. So this is a methyl. Pay close attention, class. This is not the time to even wink. You can only afford to smile, because I want you to concentrate here and get the naming clearly. Then after identifying the branch, the next thing we will ask ourselves, this carbon atom lies on which, this branch lies on which carbon atom, on what number of the longest continuous chain? So we have number 1, number 2, number 3. So it lies on the second carbon atom on along the continuous chain. So you just combine the names. You start with the numbers, which is 2. Start with the numbers, which is 2. Then you go to the alkyl group, which is methyl. Then you join with the parent name, which is propane. So this is called 2-methyl propane. Repeat after me, class. 2-methyl propane. I will give you another example so that we get used to them. So let's take another example of another branch. Example 2. Class, concentrate here keenly. Our intention is to identify the branches, but I will not tell you where the branch is unless we follow the rule. So from our rule, the step number 1, identify the longest continuous carbon chain. In our case, the longest continuous carbon chain, if we decide to count from here, we have 1, 2, 3, 4. We can also have 1, 2, 3. We can also have 1, 2, 3, 4. So our longest continuous carbon chain has 4 carbon atoms. And if it has 4 carbon atoms, it's a butane. Step number 1. Step number 2, I told you to write down. Anything else which is not on the longest continuous carbon chain is called a branch. So this is not here, so it is a branch. So identify that branch. So what is the name of this branch? Again, it has 1 carbon atom with 3 hydrogen atom, 1 less from the parent alkane. So if it has 1 carbon atom and 1 hydrogen atom less from the parent alkane, it is an alkyl group, but an alkyl called methyl. Then the next step, identify on which carbon atom does the branch lie. So 1, 2, 3, 4. it lies on the second carbon atom. So when you collect them, you start with numbering 2-methyl butane. The next one, class, another example. So suppose we have this. And suppose we have this. Just keep also this in mind. But I told you the first thing you do, you have to clothe it. They have to form a bond. Before we go to this, let's check this. First step, identify the longest continuous carbon chain. Identify the longest continuous carbon chain. In our case, 1, 2, 3, 4, 5, or 1, 2, 3, or 1, 2, 3, 4, 5. So it is 5 carbon atoms that gives it pentane. When it is pentane, that's we are done with it. Then anything else outside the longest continuous carbon chain is called a branch. So you mark the branch. This is what is there only. So this branch is also still a methyl branch, because we said it is one carbon atom with one hydrogen atom less from the parent alkane. So this is a methyl. Then identify on which carbon atom does it lie. Number 1, number 2, 3, 4, 5. So it lies on the second, which gives it the name 2. Start with 2, then methyl pentane. Class, repeat after me. 2-methyl pentane. Next one, let me do this in a fresh. Okay, let's name this first. Hydrogen atom step number 1, identify the longest continuous carbon chain, which is 1, 2, 3, 4, 5, or 1, 2, 3, 4, or 1, 2, 3, 4. So it is 5, which is a pentane. Then identify anything else that is not along the longest continuous chain, carbon chain, is a branch. So identify this branch. Then name this branch. The branch is a methyl branch. Then identify on which carbon atom does it lie. 1, 2, 3, 4, 5. It lies on the third one. Therefore, the name is 3-methyl pentane. The name is 3-methyl pentane. Then, be keen here, class. Be very keen. I'm bringing in another example that needs a lot of keenness. You clothe it. Class, be very keen here. Step number 1, as usual, identify the longest continuous carbon chain. The longest here is 1, 2, 3, 4, 5. If we decide to go this way, 1, 2, 3, 4, 5. If we go this way, 1, 2, 3, 4, 5. So we do agree that the longest continuous chain has 5 carbons. That makes it a pentane. Anything else which is not along the longest continuous chain is a branch. So identify the branch. So if this is our longest continuous chain, which means these are branches. This is a branch, not branches. So this branch is there. So what name do we give to this branch? Be keen, class. Number one, this branch has 2 carbon atoms. The branch has 2 carbon atoms with how many hydrogen atoms? 1, 2, 3, 4, 5. 2 carbon atoms with 5 hydrogen atoms. From the parent was C2H6. This is the parent alkane. The parent alkane is called ethane. Therefore, any alkane from here with 1 hydrogen atom less than the parent alkane, any compound with 1 hydrogen atom less than the parent alkane is called an alkyl. But which alkyl do we have here? Because it has 2 and we have ethane, so this becomes an ethyl. You only take the word eth, then you add the word yl. So this is an ethyl. If it is an ethyl, we want to name this. The next step is to identify on which carbon atom does it lie from the longest chain. So it lies on the 3rd carbon atom. So you will only take the number 3, then take this ethyl, then join with this pentane. Class, suppose these branches had 3 carbon atoms. If the branch had 3 carbon atoms, then it ceases to be ethyl. It is propyl. Propyl. If it was 4, it is butyl. If it is 5, it is peptyl. Peptyl from the word pentagon. If it is 6, it is hexyl. 7, heptyl. 8, octyl. 9, nonyl. And 10, decyl. So we want to look at double branches. These were single branches. So when we are looking at double branch, I want you also to pay close attention, because as we advanced, they become easier, but a little bit confusing. So to remove the confusion, I only need you to be attentive. That's the only thing I need. The password to this is being attentive, and just open your mind. So from here, we want to take an example. Example 1. Very easy. First of all, clothe it, because we said if you leave it naked, you know the disadvantages and advantages of being naked. So you clothe it with hydrogen. Step number 1, class, identify the longest continuous carbon chain. Simple. And from here, the longest continuous carbon chain we have, be keen, I start from here, 1, 2, 3. I've started horizontally. Then I want to come this way. 1, 2, 3. Or I go this way. 1, 2, 3. Or I go this way. 1, 2, 3. Or 1, 2, 3. So we all agree that it has 3 carbon atoms. That makes it a propane. Then anything else, same rules, anything else which is not along the longest continuous chain is a branch. So where are our branches? Anything else which is not here, we have a branch here. And anything else which is not here, we also have another branch here. Class, be keen here. So which type of a branch do we have? Deal with them independently, individually. So when we start with this, 1 carbon atom, 3 hydrogen atoms, 1 hydrogen atom less, methyl group. Remember, methyl group. If there were 2, ethyl group, but now here is methyl group. Same to this, is also a methyl group. Then step number 3, identify the number where the branch is, where the methyl group is making the branch. So this is 1, 2, 3. So it's making a branch on the second carbon atom. Cover this, deal with this. So in naming you say 2, again cover this, deal with this, it is 2, 2. They are branching on 2, both of them. So you take care of them by saying 2, 2. Then we have a methyl group and we have a methyl group here. When it is 1, it is methyl. When it is 2, it is dimethyl. When they are 3, you say trimethyl. When they are 4, you say tetra, not quadra, tetra methyl. So when they are here, you say 2, 2 dimethyl propane. This thing is as easy as reciting vowels. So whenever you separate a number and a number, you use a comma. Whenever you separate a number and an alphabetical name, you use a hyphen. So this is 2, 2 dimethyl propane. Example 2. Example 2. Check, look at that and look at it together with this. So class, when you see such things, do not panic. Number 1, just tell God thank you for giving you free marks. So you close it. This thing, when you are even woken up at 3 a.m., you can easily answer it because it's the easiest ever. These are carbon atoms. So I want to separate it with this. I want us to name this. Number 1, identify the longest continuous carbon chain. When we start from here, we have 1, 2, 3, 4, or 1, 2, 3, or 1, 2, 3. Okay? So the longest continuous chain has 4 carbon atoms, therefore it makes it butane. Then after that, anything else which is not along the longest continuous chain is called a branch. So we have 2 branches. So this branch is a methyl branch, as we have explained earlier, and this is a methyl branch. Then identify on which carbon atom does the branch occur. It is on the second carbon atom. So if it is on the second carbon atom and there are 2 branches, you deal with them in form of numbers as 2 for this, then 2 for this. Then because it is a methyl and a methyl group, it becomes dimethyl butane. 2, 2 dimethyl butane. Class, let's go to this. Close it to avoid coronavirus infecting it. Be keen here. This one is hydrogen. We need to separate this from that. Step number 1, identify the longest continuous carbon chain. 1, 2, 3, 4, or 1, 2, 3, or 1, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3. The longest continuous chain is number 4, which is 1, 2, 3, 4 butane. Then anything else which is not there is called a branch, which is not along the longest continuous chain. So this is a branch, and then this is another branch. So, and this branch is a methyl branch. This is also a methyl branch, but it lies on which carbon atom? So you start here 1, 2, 3, 4. So we have 1, 2, 3, 4. It lies on this and this. Again, you can also place it, number it when you come from the other side, which is 1, 2, 3, 4. So you notice, class, that when you go like this, it lies on the second, the first branch, and third, the second branch, or the second, first branch, and third, second branch. So you take it, you can start with this or like this. So you simply name it as 2, then 3, then there are 2 methyls, you say dimethyl butane. So class, as you can see, this is our naming with the double branches. This is example 3. So after naming, class, after naming, we want to name them when they have halogens. Halogens are group 7 elements. Their characteristics is that they are gaseous in state and they have color. They are colored. Examples are bromine, chlorine, fluorine, iodine. In naming these ones, you simply add here, you simply write here bromo. For this one is chloro. For this one is fluoro. And for this one, iodo. So suppose we have an example as that. Number 1, identify the longest continuous chain, which is 1, 2, 3. If it is 3, it is propane. Then because we have a bromine branching, it is bromo. This is the branch. So it is bromo. But on which carbon atom? 1, 2, 3. On the second carbon atom. So the name of this is 2-bromo-propane. Suppose we have this. This is iodine with iodine. So with iodine, identify the longest continuous chain, which is 1, 2, 3 propane. After that, identify on which carbon atom does it fall. It falls on there are 2, they fall on the second and the third, or the first and the second. So the most important thing here, we take the lowest possible values. So you take 1 and 2. You say 1, 2. We said when there are 2 it is di, but because it is iodine it is iodo propane. We are almost finishing, don't get tired. In the next few minutes we'll be done. Next example with the halogen, when it reacts with chlorine, what do we get? Number 1, identify the longest continuous chain, which is methane. It only has 1 carbon atom. Then how many chlorines do we have? We have 3. So if it is 3, it is trichloromethane. Trichloromethane is the chloroform, what we use to preserve specimen in the laboratory for biology students, and we also use it to preserve dead bodies. Chloroform, trichloromethane, this is the formula. Now the last example we have, longest continuous chain is methane. And then from here we have 4 chlorines, which makes it tetra, not quadra. Tetrachloromethane. The last one on halogens, suppose we have this. And then here we have bromine, chlorine, fluorine, and iodine. Number 1, identify the longest continuous chain, which is 1, 2, 3, 4. That is butane. Class, pay attention here. Then when we are naming this, we will use alphabetical. We'll name them alphabetical as they fall in that order. So we identify how they fall in various chains, 1, 2, 3, 4. So we can see bromine falling on 1. So you say 1 bromo, 2 chloro, 1 bromo, 2 chloro, 3 fluoro, 4 iodo, but the name is butane. Class, repeat after me. 1 bromo, 2 chloro, 3 fluoro, 4 iodo, butane. Do away with that. 1 bromo, 2 chloro, 3 fluoro, 4 iodo, butane. Our last subtopic today is on isomers, isomerism. The last one, we only have 3 examples, then we wind up, plus their chemical properties. So here we have isomers. Class, this word should not be new to you. Isomers are organic compounds with the same molecular formula but different structural formulas. Or isomers are hydrocarbons with the same molecular formula. Molecular formula is same, but structural formula is different. And if you can remember, we were doing them before. So it's easier to introduce it after doing it. So if we take an example of butane, if you are told to write all the isomers, write all the isomers of butane. The first isomer of butane is CH4. No, C2, C4, sorry. So C4H10. So C4H10. So the first isomer is C4, 1, 2, 3, 4. Then how many H? You just bond it with the hydrogen. So this is C4H10. Now we want to compare it with another compound with the same number of carbon atoms, same number of hydrogen atoms, but different structure. So if we reduce by 1 here, we get 3, and introduce that there. We're almost finishing class, don't get tired. In a few, this is where the exam is. Identify the longest continuous chain, which is propane. There are 3, 1, 2, 3, propane. Then I name the branch because the branch is on the second carbon atom, 1, 2, 3. This branch is a methyl branch. So we name it, we start with 2, then methyl propane. As you can see, class, this structure also has 1, 2, 3, 4. The C are 4. The H are 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 1 here, sorry, I didn't close it well. 10. H10. So you can see C4H10, C4H10, They are the same. But you can see this structure for C4H10 and this structure for C4H10, they are different. So that's called an isomer of butane. Butane has two isomers, this and this. We can do for pentane. As we wind up, don't get tired, class. Breathe in, out, in again, out. Another example, if you want to do for pentane, this is structure for pentane. So pentane here has 1, 2, 3, 4, 5. C are 5, and hydrogens are how many? Hydrogen atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want to get isomers of pentane. Just reduce by 1 and branch it. Branch it there. We branch it. After branching it, you name it. Identify the longest continuous chain. This is called pentane, but what do we call this? Identify the longest continuous chain as 4 carbon atoms. That makes it butane. Then we have a branch on the second carbon atom, 1, 2, 3, 4. And this is a methyl branch. So when you name this, it is 2-methyl butane. So this again can be branched. That's okay. So class, from here, the first assignment before we finish, I want you to get all the isomers of hexane, all isomers of heptane, all isomers of octane, all isomers of nonane, and all isomers of decane. That is our assignment for today. As I finish the class, I finish it with the chemical properties. This will take only 2 minutes. The chemical properties of alkanes. Number 1, we will use methane. So when methane reacts with oxygen, you get carbon dioxide and water, but they are all in gaseous form. When methane reacts with oxygen, combustion, when you burn it, they are all in gaseous state. You get carbon dioxide and water. So in this form, you can balance the equation. We have 2 hydrogens here, we have 4 hydrogens here. Therefore, you only add 2 here to have 4 hydrogen atoms. Then here we have 2 times oxygen is 2 oxygen atoms plus 2 oxygen atoms. Those are 4 oxygen atoms. But on the other side, we have only 2. Therefore, you add 2 there to make it 4 oxygen atoms. Then we have carbon atom and carbon atom. So this is combustion of methane. Then we want to see reactions with halogens. The last one, last but not least, reactions with halogens. They react with halogens alkanes react with halogens by substitution reaction. Substitution reaction. So therefore, if we have methane, you react with chlorine, you will get CH3Cl plus HCl. This one again can react to get CH3Cl plus chlorine. This you get CH2Cl2 plus HCl. HCl is hydrochloric acid. Again, this reacts with chlorine. You get CH, Cl3 plus HCl. And the last one, when this reacts with chlorine, you get CCl4, that is the methane plus HCl. But they react in the presence of sunlight. They react in the presence of sunlight. Class, these are our equations. Today, that is where we will stop our class. And I want to wish you all the best. Know that chemistry is chemistry. At least take on a daily basis 30 minutes to do mathematics, 30 minutes to do chemistry on a daily basis, 30 minutes to do physics, because these are subjects that require practicing. So you must practice them on a daily basis. We end our class today, and the next class we will deal with mathematics topic-wise. We will not handle the questions, we will just go topic by topic so that our candidates, our learners can be well informed. I take this opportunity to wish you all the best and know that we are together. Don't be intimidated by anybody from the government who is not happy with what we are doing. Our great brain capacity is at optimum, better than that person. And may he continue basking in the glory of his ignorance. Thank you. God bless you all.